In today's dynamic world, we often come across with requirements for having access to centralized shared resources. Whether it is if you're sitting in office and trying to access some network drives, or multiple servers which are trying to fetch resources from a centralized location. So in this demo, we are going to look at Amazon's EFS service and how you can integrate this deployment with Terraform. Let's get started. Let us first have a look at the business requirement. Developers have maintained a central repository where they write their codes. So in my case, I've chosen the code to be deployed or present in GitHub. And then users will be accessing the application from all over the world. And we need the code to be deployed on the servers in such a way that any change that you do from any of the centralized locations, the same code can be accessed, or you do not have to do the same change again on the second server. Once a specific change is done on one server, that same change will be immediately reflected on your second server. In this case, you cannot rely on EBS or Elastic Block Store, because the block store has to be associated with a specific instance itself. So now let us look at the solutions that we have used in this. I've used first S3. This is to serve static web page contents, whether it is an image or any other file which is hosted on your web page. And then I've used Cloudfront to serve the content across the globe, and at the same time make sure the latency is very low for all users. And the main service that I'm concentrating in this specific demo is EFS. EFS is an elastic file system which provides you flexibility in terms of accessing the resources from a centralized location. So you can mount this EFS service either with your on-prem servers or any instances which are running on the cloud itself. This helps you provide low latencies and at the same time gives you a centralized repository. EFS has two flavors of storage classes. The first one is standard storage, and the second one is infrequent access storage. Standard storage basically provides you a way to have access in a centralized manner, and if the resource, you can define your life cycle. If you feel that the resource is not being accessed very frequently, then it can be moved over to infrequent access storage, and at the same time that can help you save cost. So with this, now let's go ahead and look at the code for this deployment. Whenever you are writing the Terraform code, the first part is always to start with defining the provider, which is defined in this block. So in here, you must be wondering, I have not defined the credential. How this Terraform code will be able to log into my system? So you definitely have options to define your credentials here, but instead, if you give AWS configure, in here, you can log in with your account, the access ID, the secret key. You can define the default region and the default output format. The Terraform is so intelligent that once you have logged in successfully with this credential, it will automatically detect your AWS credential, and you do not have to provide your credentials in this specific code itself. That's one important thing. And if you have not gone through my previous video in which I have explained each and every segments, I highly recommend going through that, because in this specific demo, I'm mainly focusing on EFS. So let me quickly go through the code. First, we start with writing the code for VPC. VPC, defining the CIDR block, giving it a specific name. After defining a VPC, we started defining the subnet in which we are going to launch our specific servers. Then we have defined, this block defines a specific routing table, and within the routing table I have to associate the routes, the specific subnets. And then in order for the server to go outside and connect to the network, to internet, I've defined internet gateway. Then an important point which we always need to remember is whenever we create a default, a custom routing table, you must add a default route pointing towards the internet gateway, which you are adding it in your specific subnet. And then in this specific part, I have created the security group. The main thing that is different in terms of the previous demo is the port. You have to add one more port, which is for network file service. Port is 20449. And then in order to log into the device, I've defined the RSA key. This is going to generate my key, and I'm going to save it locally. So local is again another provider. And then I'm going to define my web instance, the web server. And on the web server, I'm going to use this provisioner to install Apache and start the HTTPD service. Then this is the main block which we are looking at. When we have to create a main EFS file system, the resource type that we use starts with again AWS and EFS file system. And this is the name which I have defined within Terraform for it to manage it. Now I want this to be created only post my security group is defined and my web instance is defined or launched. And when we are creating this, I have to give it a specific name. So that is what I have defined in the creation token, a unique name, and then any specific tag that I want to add, I can give it using tags. And when we create our EFS file system, the next part is, which is important, is your EFS mounting. When you create EFS file system, it creates mount targets. So in terms of Terraform, you can create your mount targets using this specific resource block type, which is AWS, and again EFS mount target, and this is a local name. Now this specific target can be only defined when my EFS file system is created. So I've provided the dependency in here, and once the file is created, it will be provided a unique specific file ID. So I'm calling this file system ID using AWS EFS file system. So this specific part which you see is again this specific type, and dot mynfs, and then the last part is .id, and in which whenever you are creating a mount target, that has to be in a specific subnet. So this subnet ID, which I am going to decide, I am choosing in terms of where my instance is launched. So I have the mount target is like a specific network interface, which will be mapped to my specific instance. So in here, I'm calling this as AWS underscore instance, because if we go above, in here, I'm going to follow the same trick, AWS underscore instance dot web, and 0 I've defined for the first instance, and then within that specific resource dot subnet ID. And security groups is the security group specific ID. And after this is created, I want this to be mounted to my EFS, mounted to my instance. So for this, I have created a null resource. I've given it a specific local name, and this has to be done once the mount target is created. So in here, whenever you are making use of provisioner to run remote commands, which has to be executed on a remote server, you have to define the connection parameters, how you want the Terraform to log in, the SSH type, user ID, the private key, and then this is the host instance where we want to log in. So this is calling up my public IP of my web instance. And then after logging in, what are the commands that I need to run? So this is the main command which will create the mount. So mount sudo mount -t nfs4, and then this specific part. So whenever the mount is created in your AWS instance, that will be assigned a specific IP address. So in order for me to read that, I would have to define it in the same manner. So AWS EFS mount target dot mount IP and dot mount, which is the local name within Terraform, and dot IP underscore address is again an attribute. So after the instance, after your EC2 instance is launched, then with this IP address, it is going to be mounted on my location var www.html. This is my important location with respect to my web server. So I want this specific EFS mount be mounted to this specific location. And after that, I'm just going to remove any existing content from that specific location, and then clone my GitHub repo, so that the web code which is present on my GitHub is copied to the remote server. And then this part basically creates a S3 bucket. So with this, and after creating S3 bucket, it is, again doing copying the local repo, download the main specific image, and that specific image I have to upload it to my S3 bucket. I'm defining the ACL here, and then uploading the data to my S3 bucket. So this is my static page in my GitHub repo, which I need to upload it to S3. So, and then I'm using Cloudfront. So once S3 is created, then I'm defining Cloudfront to be acting it as my front point. So that whenever the clients are trying to access my web page, this specific Cloudfront URL will get updated in my web page directory, so that the content always is being served from the Cloudfront itself. So this was all about Cloudfront. Then I'm going to make use of this remote write image. So this is to write the specific Cloudfront and add it within my web page code. And after this, finally, we start with showing the results. So enough of this specific description. Let's get started with the deployment. So to start with, always first we have to verify that the code that we have written is correct or not. Is there any syntax error or not? So for this, I would use a command as terraform validate. Once you run terraform validate, if there are no errors, it will show that the configuration is valid. And then we start with Terraform Initialization. This is to initialize and download any specific provided plugins. Now, the next step would be to define a plan. So Terraform Plan. Now, we have been running it directly with a Terraform Plan. So, but as a good practice, it is recommended that you save this plan in a specific file, which Terraform can make use of and run the deployment. So we would store this in a file as, let's say, test.out. So this is going to create a binary file, test.out, and it is going to save the plan. It will also show you the output here, but it is also going to create a specific file, test.out. In here you can see the test.out file, using which we can create our deployment. So now if I do Terraform apply, I have to make use of the same plan which I created. So test.out. So with this, now all my different resources are getting created. While this is getting created, let's go ahead and go to our AWS console and let's have a look. In here, if we go to, let's start with VPC. We can see our VPC got created, then a subnet is also created, route table is created, our internet gateway is created. So let's have a look at EC2. My instance is also being launched. This is, and if you see the instance is mapped with the web key which I have defined in my Terraform code. And again, I have also defined the security policy, security group. And within this security group, if you see the inbound rules, it is going to show you that these different ports are allowed. Now let's have a look at EFS. We can see EFS is also created with one mount target. So in here we can see this EFS is mapped to this VPC and it is launched in this specific availability zone, mapped to this specific subnet. and this is the IP address of your mount target. And at present, you can see it is creating the mount target state. It is in progress. Now let's have a look at S3. Now we can see a bucket is also created, within which we will see that our object is uploaded. Our object is also uploaded here automatically. And now let's have a look at Cloudfront. We can see Cloudfront distribution is also getting created. It is in progress. And this is my origin ID. This is the S3 bucket from where it will take the main information. And while this is getting deployed, let's come back and have a look at. So if we now see the output, it will show that all resources have been created. So 21 resources got added. And now if I see the result, in here, the browser was launched successfully, and my website is also launched with this specific image, which is being served from EC2. So if I like to show you, if you go to more tools, developer tools, and in here, let's say if we refresh this button, if you click on demo image, you can see that this is being launched from Cloudfront. And at present, the first time when you launch it, you will observe that it is saying cache miss from Cloudfront. So always the first time when the request is being made, if the content is not within Cloudfront, it will request to S3 and get that request. Now let me try to relaunch this. And if I try to relaunch this few times, and this time if I see this specific image, it is again showing me the Cloudfront URL, that this specific image is being downloaded from Cloudfront. And if I come down, this time it is going to show that it has been delivered from Cloudfront itself, hit from Cloudfront. Let me show the demo again. So with the first request, you can see here, it is a miss from Cloudfront. And with respect to demo.png, in here, you can see a hit from Cloudfront. So from the next time onwards, this is going to be served from Cloudfront itself. And if you have a look at the latency also, right, you can see here the first time it took almost 87 milliseconds. And from next time onwards, it is taking only like 18 milliseconds, 23 milliseconds. If I keep refreshing this, you can see the latency is very less for that specific image to get loaded. And that's the power of Cloudfront. So now coming back to our code. With this, I have successfully deployed all my resources. Let's say if I plan to destroy this or delete all my resources, I can just do it with one command, which is Terraform Destroy. And now when I'm destroying it, it will ask me again a permission. So I don't want to give that permission. So while running the command itself, I can make use of this auto approve option so that it will not ask me again. And once I run this, it will show me that all the different resources are going to be deleted, and we can see the output in a while that all our resources, restriction has started. All our specific resources are being deleted. And one interesting thing that I wanted to show you is, whenever you create a specific, okay, I think I had already started the restriction, so I will not be able to open this file. So this Terraform state file, terraform.tf state file, has all the details of resources that you deploy. Whenever you deploy it, for each individual resource, what is the value that is saved in this terraform.tf state, using which the Terraform knows what is the state of different components, what is the value of each and every parameter. And just in a while, you will see that all my infrastructure is deployed just by running one specific command. So at the same time, you can make use of Terraform to build your infrastructure as well as destroy your infrastructure. So I hope that you found this informative. And before we close off, I would also like to show you the mount point with respect to EFS. So for that, I have to deploy this once again. Let this specific part get finished, and let me pause the video for a while. I'll redeploy this and I'll show you the EFS mounting. And you can see that after a while, once all our resources are destructed, it will give you an output as destroy complete, the resources 21 destroyed. Now let me again create a plan. And let me get this deployed again, and then I'll show you the specific part where we can confirm that the EFS is mounted on my instance. Terraform apply. Let me just delete this part. In here, we can see that this is the IP address of my web server, which is launched. So let me try to log in. sh space -i, the web key, and then the user ID. This is the IP. So now I have logged in, and after logging in, if I use df space -h, this is going to show me the specific mount point. So I've mounted the EFS to var www./html, and this is my mount point. So if we go and check on the AWS, if you look at the EFS service, we can, once we expand this, we will be able to see the same mount point which got created. So with this, I would like to conclude this demo. I hope you found this informative. Thank you for watching.